Good morning, my dear students. In this particular video presentation, again, we'll discuss some more problems meant for class 12 of CBSE, which are very often tested in the board. The first question goes like this: solve tan inverse y minus x times dy is equal to 1 plus y square times dx. Always in any such problem, we are supposed to find out by ourselves whether it comes under variable separable form, whether it comes under homogeneous form, or comes under dy by dx plus py is equal to q, or dx by dy plus px equal to q. Now let me try to simplify here in a suitable manner. Dx by dy times 1 plus y square is equal to tan inverse y minus x, which implies dx by dy will be is equal to tan inverse y by 1 plus y square minus x by 1 plus y square, which implies dx by dy plus x by 1 plus y square will be is equal to tan inverse y by 1 plus y square. Now this is of the form dx by dy plus px is equal to q, where my p is nothing but 1 by 1 plus y square, my q is nothing but tan inverse y by 1 plus y square. Coefficient of x is nothing but p, the quantity in the right hand side is nothing but q. Now integrating factor, that is I dot f is e power integral p dy, e power integral dy by 1 plus y square, which is in fact e power tan inverse y. Now solution is given by, let me take another pen, it's not writing properly. Let me just take another pen and proceed. X e power integral p dy, x e power integral p dy is equal to integral q e power integral p dy plus c, which implies x e power tan inverse y is equal to, this is of course integral tan inverse y by 1 plus y square into e power tan inverse y dy, can be written as t e power t dt, where my t is tan inverse y. See here, if I replace tan inverse y by t, this becomes t, this becomes e power t, dy by 1 plus y square is nothing but dt. Okay, therefore here I apply integration by parts, which is t e power t minus integral e power t dt. Since integral u dv is equal to uv minus integral v du, here instead of u I have t, instead of v I have e power t. Therefore this will become t e power t minus e power t plus c. Therefore x e power tan inverse y is equal to tan inverse y e power tan inverse y minus e power tan inverse y plus c is the required, yes, the required general solution. That is the required general solution. You can even divide throughout the e power tan inverse y, then it will become x is equal to tan inverse y minus 1 plus c by e power tan inverse y. That will be the final answer. That is the way also you can write, or you can leave it as it is. I repeat, tan inverse y minus x into dy is equal to 1 plus y square into dx. Dx by dy into 1 plus y square, I am taking dy to the other side, is equal to tan inverse y minus x. I am dividing by 1 plus y square throughout. Now for tan inverse y, the 1 plus y square minus x by 1 plus y square will be my right hand side. Bringing this to this side, dx by dy plus x by 1 plus y square is equal to tan inverse y by 1 plus y square. This is of the form dx by dy plus px equal to q, where p is 1 by 1 plus y square. Other than x, whatever is there is my p. The quantity in right hand side is nothing but q. Integrating factors e power integral p dy, e power integral dy by 1 plus y square e power tan inverse by. Solution is given by, or general solution is given by, x e power integral p dy equal to integral q e power integral p dy plus c. X e power tan inverse y is equal to integral tan inverse y by 1 plus y square d power tan inverse y dy can be written as integral t e power t dt, where t is tan inverse y. This is t, this is e power t, dy by 1 plus y square is nothing but dt. Derivative of tan inverse y is 1 by 1 plus y square. For t e power t minus integral e power t dt. So the form u dv, integral u dv is uv minus integral v du. Instead of u I have t, instead of v I have e power t, u dv. This is my v, this is my u. Now for uv t e power t minus v du e power t dt, t e power t minus e power t plus c. X e power tan inverse y is equal to tan inverse y e power tan inverse y minus e power tan inverse y plus c. That is the required general solution. That's the way it's being done. You can even divide throughout by e power tan inverse y. Here I should write c e power minus tan inverse y finally. That's the final answer you are supposed to remember anyway. That will be the final solution. That will be the final solution. I hope it is not difficult for you to follow. It's an easy one to follow. It's not at all difficult to follow. Okay, it is not at all difficult. It's just simple result to follow. Just see here. Now, next one goes like this. Next one is again solve x dy minus y dx times y sin y by x is equal to y dx plus x dy times x cos y by x. This is a question given to you. I am not going to write the question. I am going to start with the answer. Okay, just here. This is the first step given to you, which will automatically will give you okay, see here, it will become xy sin y by x dy minus y square sin y by x dx will be is equal to xy cos y by x dx plus x square cos y by x dy. Now, which will imply you xy sin y by x minus x square cos y by x times dy is equal to xy cos y by x plus y square sin y by x times dx, which will imply you dy by dx is nothing but xy cos y by x plus y square sin y by x divided by xy sin y by x minus x square cos y by x. I'm sorry, there is an unnecessary bracket here along cos y by x. I should have bracket is closed only here, x square cos y by x. Let me just check whether what I have written is correct or not. X dy minus y dx times y sin y by x equal to y dx plus x dy times x cos y by x. Since y by x is involved, I'll try to bring it as the form dy by dx equal to something, some function of x comma y. Remember carefully. I'm not going to bring it to the form dx by dy. Remember carefully. Now for xy sin y by x dy minus y square sin y by x dx is equal to xy cos y by x dx plus x square cos y by x d. Here again dx. Sorry, that's the reason why I said I'll check once again. This is dx. Yeah, dy only. Sorry, x square cos y by x dy only. Sorry. Now, therefore, xy sin y by x minus x square cos y by x dy is equal to xy cos y by x plus y square sin y by x dx. Therefore, dy by dx happens to be xy cos y by x minus y square sin y by x by xy cos sin y by x minus x square cos y by x can also be written as dy by dx equal to, let me take x square as common, y by x cos y by x plus y square by x square sin y by x divided by, take x square as common, y by x sin y by x minus cos y by x. I'll get x square getting cancelled. Remember carefully, only the homogeneous part let me explain orally. I'll take this quantity as f of x comma y. Remember carefully, the right hand side function to be f of x comma y. Take f of lambda x comma lambda y. Here lambda y, lambda x, lambda gets cancelled, lambda, everywhere lambda will get cancelled. It will get reduced to lambda power 0 into f of x comma y. I repeat, taking this as f of x comma y, I'll be able to prove f of lambda x comma lambda y to be equal to lambda power 0 into f of x comma y. In such case, I'll come to the conclusion the right hand side is a homogeneous function of degree 0. Then this will be a homogeneous function. This will be a homogeneous function. That part I am just dictating because it will occupy more space. Okay. Therefore, here put y is equal to y vx dy by dx now becomes v plus x dv by dx. Therefore, my 1 will automatically become now v plus x dv by dx happens to be v cos v plus v square sin v divided by v sin v minus cos v, which will imply you x dv by dx is v cos v plus v square sin v by v sin v minus cos v minus v, which implies x dv by dx is v cos v plus v square sin v minus v square sin v plus v cos v divided by v sin v minus cos v. V square sin v gets cancelled, which will imply you x dv by dx happens to be 2v cos v by v sin v minus cos v, which implies integral v sin v minus cos v by v cos v is equal to twice of integral dx by x, which will automatically imply you integral sin v by cos v dv minus integral dv by v. See here, integral here cos v will get cancelled, dv is missing, is equal to 2 log x plus log c, which will imply you, I will write it as minus log mod cos v. See here, multiplying two minus signs, derivative cos v will be there in the numerator. Minus log v is equal to log cx square, which will anyway gets reduced to minus of, or otherwise I will get, there's a minus sign here, no? Am I right? Am I going wrong somewhere else? This is plus, minus cos v only. Therefore, I end up with minus log of v cos v is equal to log cx square. Let me rub the initial part to simplify the final 3 steps. Let me rub only this part. Let me just rub only this part. Here I mean to say automatically, here I mean to say log cx square is equal to log 1 by v cos v, which implies cx square equal to 1 by v cos v, which implies you can very well say cx square is equal to secant v by v, which implies cx square equal to secant y by x into x by y. One x gets cancelled, which implies secant y by x equal to cxy is the required, this is the required general solution. I'll just explain the whole lot once again. This part I have just dictated. I'll repeat once again. I'll take the right hand side, the whole thing is f of x comma y. Replacing x by lambda x, y by lambda y, I'll be able to prove f of lambda x comma lambda y to be is equal to lambda power 0 into f of x comma y. Now for right hand side will be a homogeneous function of degree 0. In such case, this particular equation will be a homogeneous differential equation. That part I have dictated, I haven't written down. Now for this is of the form dy by dx equal to f of x comma y. I'll put y equal to vx. dy by dx becomes v plus x dv by dx. Now for v plus x dv by dx, 1 becomes is equal to v cos v plus v squared sin v by v sin v minus cos v. Take this v to the other side and take LCM. V cos v plus v squared sin v minus v squared sin v minus into minus plus v cos v by the denominator. V squared sin v gets cancelled. For x dv by dx is 2v cos v by v sin v minus cos v. Integral v sin v minus cos v by v cos v dv is equal to twice of integral dx by x. Dividing individually, here v gets cancelled. Sin v by cos v dv minus here cos v gets cancelled. Integral dv by v is equal to 2 log x plus log c. Multiply 2 minus signs here. Derivative cos will be there in the numerator. Minus log cos v minus log v is equal to log cx square. Here x square and apply product rule logarithms. For minus log v cos v, taking minus as common, applying product rule. Minus log v cos v is equal to log cx square. Log cx square is log 1 by v cos v, taking this minus sign as a power. Therefore, don't cancel log, only equate the quantities. Cx square is 1 by v cos v. Cx square equal to, take this to the numerator, secant v by v. Cx square is secant y by x. This x goes up, v is y by x. Therefore, 1x gets cancelled. Secant x y by x equal to cxy is the required general solution. That will be the final answer. As usual, I'll anyway check for the calculations, then I'll upload. If there is any correction, I'll add the correction and upload. Otherwise, I'll upload as it is. This is of course a lengthy problem, but it's not difficult to follow. You need to apply your mind and do. Thank you students for patient watching.